Okay, so let me first ask you to do the following first for the next minute or two. Could you go ahead and write down the restrictions for these 4 questions? And also, as we learned yesterday, the common denominator, it's going to be the major focus right here. So can you write down the common denominator for all 4 of these cases? And I would suggest you to write them in factored form. So again, put down all the restrictions and common denominators. Okay, so let's take a moment. Okay. I think out of these 4 questions, if you take a quick glance, the easiest common denominator to write out would be question number 2, because the common denominator is just x plus 2. Okay, now something that you should be really aware of is that whenever you see something like this, so with a square, you should prompt yourself to consider factoring. So what is x squared minus 9? We write this as x plus 3 and x minus 3. Okay, and then for question number 3, we have x squared plus 3x plus 2, and that will be factored into x plus 2 and x plus 1. Okay, so so these are the denominators. Okay, these are denominators, and we say, all right, now that we have all the denominators factored, and we can now consider what the common denominators would be. So for question number 1, the common denominators would be, well, you basically just pick out all the elements. Okay, you say, well, I see an element of x plus 3, and also see an element of x minus 3. So that would be, those would be the common denominator. And the restrictions would be x cannot equal to 3 and negative 3. So if you know your common denominator, that would also help you write down your restrictions. Okay, for question number 2, the common denominator is x plus 2, and that means x cannot equal to negative 2. And for number 3, the common denominator would be, you have x plus 1, and you also have x plus 2. Okay, so you can see the x plus 1 right here, and you can also see the x plus 2 right here. So the common denominator would be x plus 1 times x plus 2. And your restrictions would be here, in this case, x cannot equal to negative 1, and x cannot equal to negative 2. And for the 4th one, the common denominator would be x plus 1, and then x plus 4. Okay, so see x plus 1, and you also see x plus 4, and so x cannot equal to negative 1 or negative 4. So before we move forward, any question regarding on how to find out the common denominator? Okay, so basically we just pick out all the unique ones, and then we say, all right, that's what we are going to see. And if you are okay, now let's start with number 2. I think number 2 is a lot easier to deal with. So if you're okay with common denominators, let's look at number 2 first. So I'm going to rewrite this at the center of the page, or the box. Now, and ever since we started school, I said that notations are very important. Yes. Oh, sorry. Yes, x plus 2. Yeah, ever since the beginning of school year, I said notations are very important. And for those who are continuing to pre-calculus, I would tell you that your notations will be, notations will play a bigger and bigger role in the future, and that will be your make or break factor down the road. So we have the common denominator, which is x plus 2, and we are going to multiply x plus 2 on both sides. And again, based on what we learned yesterday, we share a common sentiment, which is that we hate fractions. We do not like fractions. And one way to not have fractions is to not have a denominator. If there's no denominator, hey, we don't have a fraction. So that's the idea behind multiplying by the common denominator. And in this case, the x plus 2 are gone. They are gone. So we have x minus 1 on the left, x squared plus 2x minus 3 on the right. Okay, again, the purpose, okay? So I'm going to ask you, why are we multiplying common denominator? And I hope you can answer the question. We don't like fractions. We don't like denominators. And we are going to multiply common denominator on both sides so that we can have just numbers without fractions. And now we're going to group things all together on the same side. So we have x squared, and we minus x on both sides. So on the right-hand side, we're down to just plus x. And we're going to have plus 1 on both sides. So minus 3 plus 1, it's minus 2. So now we can factor. Okay, give you a moment. See if you can factor this. X squared plus x minus 2. Can you factor them? Okay. Can you factor them? So two numbers that were multiplied to give you negative 2. And yet add up together will give you a plus 1. So these two numbers must be positive 2 and negative 1. So you have x plus 2 equal to 0, or x minus 1 equal to 0. That means x is equal to negative 2 and x is equal to 1. All right, so so we have two answers right here. Or do we? Do we have two answers? Why not? Yeah, so after you write down your answers, make sure you double check with your restriction. And at the very beginning, it says x cannot be negative 2. So even though we're very excited to find out two answers, and one includes a negative 2, and we say, well, too bad. That coincides with our restriction, and that cannot be our solution. So our only solution is x equals to 1. Okay. All right. So that's number 2, simple one. Okay. So now let's move back to number 1 right here. Number 1 could be a little bit more challenging. All right, so let me go ahead and write down the equation first. We have the x over x minus 3, and then I have 2. And please write down the factored form. It'd be a lot easier if you write down the factored form. All right, so we have the equation here, and we are about to do something. And that is, we do not like fractions, and we will multiply by the common denominator. Okay, now the left-hand side is a lot easier to handle because you have a single term right here to handle. So on the left, x plus 3 times x minus 3, multiply by x over x minus 3. So what happens to the x minus 3? They will get canceled out, which is lovely. So we have x times x plus 3 on the left. So we just leave it there. You don't have to rush to multiply in or distribute. Just leave it there for the moment. Now let's take care of the right-hand side very, very carefully. Please be aware that this is subtraction. and we have something on the outside being multiplied. And that means it will be distributed to both terms. Okay, so now I'm going to write this out, okay, in the long way so they can see how it's being distributed. So hope nobody would get confused. All right, so I'm distributing. Okay, I'm distributing the term on the outside to both terms. All right, can everyone see the distribution right here? And based on the distribution and see what we can cancel out. Well, x plus 3, they are canceling each other out. X minus 3, they are also canceling each other out. All right, so and then on the other side, we have x plus 3 being canceled out, so we are down to x minus 3. So on the right, we have 2, and then minus x times x minus 3. Okay, and on the left, we have x times x plus 3. Okay, so again, make sure you can see the distribution. And now we are going to multiply out the terms right here. And then we are going to combine some like terms here to squeeze some space. I'm running out of space here. Okay, so I'm going to move everything to the left. So I'm going to add x squared on both sides. So we have 2x squared. And then we're going to minus 3x on both sides. So they will be gone. And then going to have a minus 2 and would equal to 0. Okay, so take a moment. Make sure that you can see how I am manipulating the terms. What can you see here? 2x squared minus 2 equal to 0. What can you see here? You see anything in common? Okay, so we can say, well, we are writing the 2's twice. Maybe it's a good idea to factor it out. And after you factor out, you will see x squared minus 1, which becomes x plus 1 and x minus 1. And to make it 0, so you will have x plus 1 equal to 0, x minus 1 equal to 0. So x is equal to -1 and x is equal to 1. So you have these two answers, and they do not coincide with our restrictions. So apologize for not giving you a lot of room to write here. Might be a good idea to write this on a paper. Okay, but your handwriting, make sure you can keep track. So I would say a few challenges right here. The first major challenge is probably going to be the fact that can you identify the common denominator? Okay, that's the first challenge. If you could find out the common denominator, the second challenge would be like, well, why do we care about the common denominator? Because we are about to multiply the common denominator on both sides so that we no longer have a fraction. Okay, as you can see right here, we do not have fractions anymore. And then, but as you do that, there's another challenge, which is the fact that are you aware of distributing when there's an addition or subtraction? Okay, make sure you're distributing the common denominator that's being multiplied very effectively, correctly. Okay, and at the end, once you have the answers, make sure you double check with the restrictions so that you know they are the points. Okay. All right, let's take a look at number 3. So we have the common denominator here. So we have x minus 1 over x plus 1, and x minus 1 over x squared plus 3x plus 2. Oh, sorry, I should write down the factored form. That'll be a lot easier to see. Plus 2x over x plus 2. Okay, so it's like what we did earlier. We're going to multiply by the common denominator. Okay, so we have x plus 1 being canceled out. So on the left, you've got x plus 2 times x minus 1. So right here, I would say you will need to be ready to do FOIL. And then on the right-hand side, so this is being multiplied into the parentheses because of the plus. So for the first fraction that you're multiplying into, well, the denominators, the denominator there for the first fraction here, they're the same as this one, so they would be completely canceled out. So you're left with x plus 1. For the second fraction, okay, you have x plus 2 in the denominator. So x plus 2 is being canceled out, so you have x plus 1 left. Okay. So on the left, you have x squared plus 2x minus x minus 2. And then on the right, you have 2x, x minus 1 plus 2x squared plus 2x. And you have this on the left. All right, so you have a lot of like terms right here waiting for you to combine. So you have, you subtract x squared on both sides. So on the right-hand side, you have x squared. Subtract x on both sides. On the right-hand side, you have 2x plus 2 on both sides. So you have a 1. And you would go ahead and factor this. So you need to think of two numbers that can multiply to give you 1 and add up together to give you 2. Well, you have only one choice, and that is just 1. 1 plus 1, it's 2. 1 times 1, it's 1. So therefore, x plus 1 is equal to 0, and x is equal to negative 1. And however, that's also the restriction. So we would say, in that case, we do not have any solution here for this particular problem. Okay. So again, make sure you have the techniques. Okay, multiplying, distributing, FOIL. Okay, combining like terms. All right. So for number 4. All right, for number 4. So you have x plus 3, x plus 4 on the right, and then you have x over x plus 1 plus 3 over x plus 4. So we will again multiply by the common denominator. So on the right-hand side, the x plus 4 will get canceled out. So you have x plus 3, x plus 1. Okay. On the left, when you multiply this with this fraction, the x plus 1 would get canceled out. So you have x times the remaining factor, that is x plus 4. And then when you multiply the next one right here, when you multiply this common denominator to the second fraction, the x plus 4 will get canceled out. So you are left with 3 times x plus 1. So you will do FOIL on the right, and you would expand on the left. Okay. So so you have all these right here. Okay. Well, if you subtract x squared on both sides, x squared's gone. If you subtract 3 on both sides, the 3 is gone. So you are down to 7x, it's equal to 4x. And if you combine like terms, you subtract 4x on both sides, you have 3x equal to 0, and x equals to 0. And that is not a restriction. Okay, so we say, all right, x equal to 0, and that is our solution. Okay. So understand it's quite challenging. So your practice, it's very much needed. Making sure that you know how to tell the common denominator, I would say that's a really key practice. And also your routine. Okay, are you able to multiply, distribute? Okay, in all these cases. All right, now let's take a look at the word question, the word problems down below. They are the easy ones that we covered yesterday. Again, the idea is this. We're talking about these jobs, right? These jobs, and we're talking about in the individual rate, and also the rates then when things are being done together. So the annotation would be like this. Okay, so one pump can fill a tank in 4 hours. Another can fill the tank in 3 hours. Working together, how long would it take to fill the tank? So the idea here is that we have rate of pump number 1 plus rate of pump number 2 must equal to the rate together. So what is the rate for number 1? 1/4. And the rate for pump number 2, it's 1/3. So meaning that one job being done in 4 hours plus one job being done in 3 hours, it's going to equal to one job being done in X amount of hours, presumably less than 3, because they're working together. So in this case, with this equation, what is the common denominator here? With these 3 fractions, what's the common denominator? 12x, okay, 12x. So we will multiply both sides by 12x. Okay, we multiply both sides by 12x. So after we multiply both sides by 12x, so on the left, well, let's do the right side first. The right side, it's easy, it's just 12. On the left, don't forget that you have to distribute the 12x into 2 fractions. So 12x divided by 4, it's 3x. And 12x divided by 3, it's 4x. So we have 7x is equal to 12. So x is 12/7, meaning that if both pumps are working together, so it is around, now you don't need to do this, but since I have a calculator next to me, so the number, it's 12/7, or roughly 1.71 hours. Okay, you can just give me the fraction, but I'm just giving you the number so that you have an idea how working together will be faster than working individually. Okay, number 6 sounds like it's like the question that we did yesterday. So again, we have the rate of Mrs. Scoggins, and we have rate of Miss Kitagawa. It's equal to the rate of both together. So we have 1 over 15 minutes plus 1 over 25 minutes. And how long would it take if they work together? So we say, what is the common denominator here? 25 and 15. Okay. Now, if you think it's kind of hard to think, well, let me show you how to think about this. You can think of 15 as 5 times 3. And you can think of 25 as 5 times 5. So if you want to have a common denominator, that means all denominators must have 2 5s and a 3, which is 25 times 3, and that is, well, hold on, that's also an x as well. So so you have 75x. So if you're not very fluent with the multiples of 15 and 25, you can just break it down to factors, and we just analyze it just like how we do it with the x plus 1, x minus 4, those kind of stuff. And you can find out the common denominator being 75x. Okay, so the right hand side is pretty straightforward. 75x divided by x, you got 75. And on the left, you distribute. So 75x divided by 15, that is a 5. So you have 5x. And then 75x divided by 25, you get 3x. So you get 8x equals to 75. So x is equal to 75 over 8. So roughly like 9 point something. It's 9.375, okay, minutes. Okay, so if there's one skill that would really determine your success in this on this topic, and that would be your ability to determine the common denominator. Okay. Now go ahead, turn to the back page, and try to do these problems. Okay. Okay, for the more challenging problems down below from question 3 through 6 on the worksheet. So let me go ahead and make sure that you have all the common denominators. So at least you know you're not heading to the wrong track. So in order to determine the common denominator for these questions, I would need to make sure that I factored everything possible. So for this one right here, n squared plus n, it will be much better to look at it as n times n plus 1. Okay. So in that case, our common denominator would be n times n plus 1, because you have the n right here, and you also have the n plus 1 right here. So you have n and n plus 1. And in this case, the restriction would be n cannot be 0 or -1. Okay. So that's for number 3. Okay. So see if you can find a pattern on how to get the common denominator. All right, right here, see m squared minus 4. So you would immediately factor this into m plus 2 and m minus 2. Okay, m plus 2 and m minus 2. So if you look at the common denominator, you have m minus 2 on both fractions, and also the m plus 2 here. So you include both m plus 2 and m minus 2. And the restrictions would be m cannot equal to 2 or -2. Okay. So again, whenever you see something factorable, you do factor them. Okay. All right. And then for number 5, you have 2 fractions here. You have a fraction with k and the other fraction with k plus 2. So the common denominator must be k and k plus 2. So the restrictions would be k cannot be 0 or -2. Okay, so that would be for number 5. K times k plus 2 would be your common denominator. And for number 6, we see 3 fractions right here. We see a w, we see a w plus 2. So the common denominator would be just w times w plus 2. So w cannot equal to 0, and w cannot equal to -2, just like that. Okay, so so make sure you go home and practice multiplying out both sides by the common denominator. And when you find out the answers, make sure you check with the restrictions to make sure that it doesn't have any kind of conflict with the restrictions. Okay.